Hey everyone, and welcome to The Explainer. I am absolutely thrilled to have you here today. If you've been following the tech space lately, you know that artificial intelligence is moving at, well, literally lightning speed. We're seeing incredible new foundation models dropping what feels like every single week. But for the modern tech architect, you know the real challenge isn't just marveling at these models. It's figuring out how to actually build robust, enterprise-grade systems around them. So today, we're demystifying modern AI architecture, layer by layer. We're going to build an AI architectural blueprint together, going from the very first line of code all the way to a fully scaled production system. Let's get into it.
Here's our construction roadmap for today. 1. The new AI engineer. 2. Foundation, build versus buy. 3. Trusting agents with actions. 4. Guardrails, governing AI quality. 5. Scaling, routers and gateways. And finally, 6. The system and the moat.
Okay, let's dive into Section 1, the new AI engineer, the paradigm shift.
Take a look at how much the workflow has shifted from traditional machine learning to modern AI engineering. On the left, you've got the old way. You'd start by painstakingly gathering data. Then you'd train a model from scratch. And finally, maybe months or even years later, you'd build a product around it. Honestly, it's like spending years engineering a custom car engine from scratch before you even know if people want to buy the car. But look at the right side. The new workflow flips this completely on its head. It goes product, then data, then model. Think of the modern AI engineer less like an engine designer and way more like a Formula One pit crew. You're leveraging incredibly powerful engines, these foundation models, that are already built for you. Your job now is to rapidly prototype the product, get it on the track, see how it performs, gather telemetry data, and just iterate as fast as humanly possible.
Because these foundation models are so readily available, practitioner roles are actually shifting much closer to full-stack engineering. You really don't need a PhD in machine learning to start building anymore. Web developers and full-stack engineers are jumping right in, creating the product first to test the market, and only investing heavily in custom data and specialized models once that product actually shows promise. It's an incredibly fast-paced, product-first approach to prototyping.
Moving right along to Section 2, Foundation, build versus buy. The architect's evolving role.
Navigating model adaptation can honestly be pretty confusing, but I absolutely love using the pizza crust analogy to make sense of it all. You see, deciding whether to build a model from scratch or buy access to one just isn't an all-or-nothing choice anymore. The pre-trained foundation models out there, like GPT-4 or Gemini, they are like excellent store-bought pizza dough. You don't need to go out, harvest your own wheat, and make the dough from scratch to make a fantastic pizza. You just buy the dough. Then you use prompt engineering and RAG, which stands for Retrieval Augmented Generation, as your custom toppings. That's how you flavor the AI with your specific business context. And if you really need to alter the fundamental behavior of the model, well, you use fine-tuning, which is basically like applying specialized baking techniques to perfect that crust. The modern architect's job is really knowing exactly how to balance these three techniques.
All right, Section 3, Trusting Agents with Actions, Managing Enterprise Trust.
Now, before we get into the enterprise risks, let's just make sure we're on the same page about what an AI agent actually is. An agent is a system that perceives its environment, processes information, plans a sequence of actions, and then actually executes them to accomplish your task. So it's not just a basic chatbot that answers questions, it's an AI that acts as a brain, figuring out how to use different tools to get a job done on its own.
So the crucial point here is how this logic flows, especially when we differentiate between a safe read action and a potentially dangerous write action. An agent generates a plan, validates it, and executes it. Now, if the agent is just reading a database to answer a simple question, the risk is relatively low. But a write action, something like editing a production database, sending a binding email to a client, or initiating a financial transaction, that carries massive enterprise risk. And that's exactly why step 2 here, validating the plan, often requires a strict human in the loop.
This quote really hits the nail on the head. Just as you shouldn't give an intern the authority to delete your production database, you shouldn't allow an unreliable AI to initiate bank transfers. I like to call this the bank vault keys for a new intern analogy. You would literally never hand the master keys to the bank vault to an intern on their very first day, right? No way. Similarly, you just cannot give a probabilistic, sometimes unreliable AI agent the unsupervised power to make critical database edits or initiate bank transfers. To safely manage these write actions, your architecture absolutely must include explicit human-in-the-loop validation checkpoints before those actions ever get executed.
Which brings us perfectly to Section 4, Guardrails, Governing AI Quality, Managing Probabilistic Systems.
To manage the inherent unpredictability of AI, we add input and output guardrails to our blueprint. Because AI models are probabilistic, which basically just means they are always guessing the next most likely word, they are prone to hallucinations and unpredictable behavior. Think of the output guardrail as your head kitchen inspector. Before a dish ever leaves the kitchen and reaches your customer's table, this inspector checks it. Is it factually correct? Is it safe? Does it contain any toxic language or accidentally leak personally identifiable information? Output guardrails act as this secondary, often specialized system that scores and verifies the AI's generation to ensure absolutely nothing harmful or hallucinated makes it to your end user.
Moving to Section 5, Scaling, Routers and Gateways, Transitioning to Production.
Now let's add the next critical piece to our factory, the router. If you think of your AI platform as an automated bottling factory, you wouldn't send every single bottle down the exact same super expensive conveyor belt, right? If a user asks a simple, straightforward query, the router dynamically directs that traffic to a smaller, faster, and much cheaper model. But if the query is incredibly complex, it routes it to your most powerful, heavy-duty foundation model. This is exactly how smart architects conquer latency constraints and manage those massive computing costs when scaling to production. And to wrap this whole production line together, we introduce the model gateway. If the router is our conveyor belt, the gateway is the entire logistics hub. It provides one single, unified interface for your application to talk to dozens of different models. It smoothly handles all your API access tokens, it manages semantic caches so you don't have to waste time recomputing answers for questions you've already seen, and it handles request tracing so you can easily monitor your system's overall health. It basically takes all the chaos of interacting with multiple AI providers and streamlines it into one beautiful, well-oiled machine.
Finally, Section 6, the system and the moat, competitive differentiation.
This is the big question. If everyone out there has access to the exact same foundational models and the exact same gateways, what actually makes your AI application special? Well, the source outlines 3 types of competitive advantages: technology, distribution, and data. Now, core technology is largely becoming a commodity. Distribution usually favors the massive tech giants. So what is your moat? It's number 3, harnessing data-centric AI and proprietary user feedback loops. This is your secret family recipe. Your competitors can go out and buy the exact same pizza dough, but they do not have your specific proprietary data loop that is constantly taking in user feedback, refining task-specific models, and making your application uniquely brilliant for your specific customers.
So what's the ultimate advice to thrive as an architect right now? You have to step back and look at the forest, not just the trees. Avoid premature over-engineering and focus on solving system-level architecture problems. It's about figuring out that balance of RAG versus fine-tuning. It's about conquering latency with routers and caches. It's truly understanding that an enterprise AI application isn't just a clever prompt typed into a model. It's a grand interconnected system where every isolated part, the agents, the guardrails, the gateway, they all have to collaborate flawlessly.
I want to leave you all with a final, slightly provocative thought to chew on today. Foundation models are growing in capability every single day, and they are often eating up the functionalities the developers previously built into the application layer. So ask yourself, is your secret family recipe, your proprietary data, and that user feedback loop deep and robust enough to keep your system from becoming completely obsolete when the next massive model drops? That is the ultimate challenge for the modern tech architect. Thank you so much for joining me on this explainer today. I really hope this blueprint helps you build something incredible. Keep learning, keep building, and I will see you next time.